Hydrogen has emerged as a promising clean energy source that has the potential to replace fossil fuels in various sectors, including transportation, power generation, and industrial processes. However, its widespread adoption is hindered by the challenge of storing it in a safe, efficient, and cost-effective manner. In this lecture, we will explore the various methods of hydrogen storage and their importance. One of the most promising methods of hydrogen storage is through compression. Hydrogen gas can be compressed to high pressures of up to 700 bar, which significantly increases its energy density. Compressed hydrogen is currently used in fuel cell vehicles, where it is stored in high-pressure tanks. The main advantage of compression is that it is a well-established technology, and it allows for fast refueling times, similar to gasoline vehicles. However, it also has some limitations, including the high cost of compression equipment and the need for heavy and bulky tanks, which can reduce the overall efficiency of the vehicle. Another method of hydrogen storage is through liquefaction. Hydrogen can be cooled down to -253 degrees Celsius, which turns it into a liquid form that has a much higher energy density than compressed hydrogen. Liquid hydrogen is currently used in rocket propulsion and as a fuel in some transportation applications. The main advantage of liquefaction is that it allows for even higher energy density than compression, making it a promising option for long-range transportation. However, it also requires significant energy input for cooling, and the tanks are bulky and require insulation to prevent heat loss. Hydrogen can also be stored in a solid form using metal hydrides. Metal hydrides are compounds that can absorb and release hydrogen gas under certain conditions. The main advantage of metal hydrides is that they can store hydrogen at lower pressures and temperatures, making them safer and more practical for some applications. However, they also have limitations, including low hydrogen storage capacity and slow hydrogen release rates, which can limit their usefulness in some applications. Another promising method of hydrogen storage is through chemical hydrogen storage. In this method, hydrogen is chemically bound to a solid material, which can release hydrogen gas upon heating or chemical reaction. The main advantage of chemical storage is that it can store hydrogen at ambient conditions, making it a promising option for stationary applications, such as power generation. However, it also requires significant energy input for releasing hydrogen gas, and the solid material needs to be regenerated after use, which can increase the cost and complexity of the system. In conclusion, hydrogen storage is a critical aspect of the hydrogen economy, and the development of efficient and cost-effective storage methods is essential for its widespread adoption. Each storage method has its advantages and limitations, and the choice of the appropriate method depends on the specific application and requirements. With continued research and development, it is hoped that new and innovative storage solutions will emerge, making hydrogen a more practical and attractive energy source for a sustainable future.